10-point tizzy, or that's 10.2 in my speak. We're going to be talking about arcs and central angles in a circle. All right? So let's get started on what we're learning about. What is a central angle? A central angle is the angle formed by two radiuses, or in this case, it's called radii. All right? That's the plural of radius. Plural of a radius. It's like pegasi or fungi. All right? So it's the angle formed by two radius with its vertex in the center of the circle. So we have an example right here. We have AB, which is a radius because it starts in the circle center, and we have BC, which is a radius. And this forms an angle, and that is 100 degrees. This would be a central angle, right? It's in the center, and it's an angle. Pretty intuitive name. So that is a central angle. All right? Now, a fun little fact, I'm not going to go to this right now. Central angles and intercepted arcs. Well, let me tell you what an intercepted arc is. An intercepted arc is just when you have this angle, right, these two radiuses, they make an arc. An arc is just a portion of the circle, a portion of the outside of the circle, or a portion of the circumference. That would be my arc. All right? It's my arc, that's my central angle. And what I know is that the measure of the central angle is going to be equal to the measure of the arc. So if my central angle is 100 degrees, my arc is also 100 degrees. That's it. Pretty straightforward, right? So if ABC is 100, that's my central angle. And we know AC, which is the arc, is also 100 degrees. Now, how many degrees total are there in a circle? Just for today, we're going to reference back to this a lot. How many degrees total are there? That is correct. There are 360 degrees in a circle. Don't forget it, okay? Total 360 all the way around. All right, let's use this information and do some problem solving. We're going to find two measures. All right, we're going to find the measure of arc AB and arc ADB. Now, here's an important thing to mention here. There's two things I want to teach you. One, that little symbol right there, right? That means arc. So when you see that little curve thing on top, that's saying look for the arc. That's how I know it's arc AB and arc ADC. Arc. And two, well, that's actually just what I wanted to say. So arc AB, all right, is right here. Well, the central angle is 50 degrees. So we know arc AB is also going to be 50 degrees. Pretty straightforward. Now what I also want to find is arc ADB. All right. Well, where is ADB? ADB is, well, I go from A to D to B. You have to follow this order, okay? So let's try it this way. Let's go in order. A all the way around to D, all the way around to B. All right? That's arc ADB. How am I going to find that? Well, here's an interesting little fact, right? We know that the whole circle is 360 degrees, right? That's my whole thing. All right, that's my whole circle. Whole circle. This little portion right here is 50. So if I take away 50 from this, that tells me what the other part of the circle is. So that would be 310 degrees. So the other part right here is 310 degrees, right? I just did 360 minus 50 to find the other part. So this whole arc, what would it be? 310 degrees. Sweetness in this house. Second part of this lesson. Find the measure of NPM, all right? That's arc NPM, and angle NLM. Well, let's do this. Here is our arc, and here is our angle. Now, how are we going to do this? You might be thinking, oh, Mr. Masigo made another mistake. He didn't put any numbers in there. Well, actually, I did. I did this just fine. You'll see that this central angle formed, right? L is our center. This is a straight line. So we know that this is a diameter. This is a diameter. And this diameter is straight, and it's 180 degrees. right? Because it's a straight line. Well, if my angle is 180 degrees, what is my arc? It will also be 180 degrees. And that's it. So my angle is 180 because it's a straight line. A straight line is always 180. My central angle is 180. Straight line. And the arc, therefore, has to be also 180. So, a little conclusion that we can reach, a diameter always makes a 180 degree arc. All right? This diameter will always give us a 180 degree arc. All right, let's get to a little more challenging problems. All right, we're going to find angle DCB and ACD. Well, let's go for it. Our first part right here. We know that DB, this outside arc is 32. So what do I know my inside angle is? Well, it's also going to be 32, right? My central angle is going to be 32 degrees. Easy enough. Sorry, it's annoying me that it's not blue. I want to stay consistent today. That is 32 degrees. So if it's asking me what is DCB, we know this is 32 degrees. Now my next one that I'm looking for is ACD. My second part that I'm looking for is ACD, right? I want to find out what this angle is. Well, how the hell am I going to do that? Well, if you're thinking ahead of me right now, you probably have figured out that ACD and DCB is a straight line, so they are a linear pair or supplementary, right? So to figure out what ACD is, all I have to do is 180 minus 32, and that will give me 48 degrees. Sorry, 148 degrees. So this would be 148 degrees, like so. And that's it. If you know you have a straight line, your central angle straight line, it has to add up to 180, so you just have to know that they're supplementary. 180 minus 32 equals 148. All right, in this case, let's get a little harder. Turn it up a little. Turn it up. We're going to find arc AD, the measure of arc AD, and the measure of arc AC, right? AE. These are arc symbols. I know these are arc because of the little curve right here. I'm going to find the measure of these two arcs. Well, what do I know? I know BCE is equal to 40 degrees. Well, what is that going to help me figure out? Well, before we even look at this, you know what I'm going to do? I'm just going to start filling in the angles, all right? And then we can answer these questions. So let's fill in the angles first and then answer the questions. I think that's a good method. Fill in angles, answer questions. Fill in angles, let's answer the questions. Well, here's my tip. The first tip to filling in angles is if you ever see a straight line or a diameter, all right, like so, you know that angle is 180 degrees. So like, look over here, AB is a straight line. So I know that's going to be 180 degrees, right? This part of it is 40. And now, how can I find ACE, right? Because this is my straight line. Well, I would just do 180 minus 40. All right, just fill in these angles. Just fill them right in. And that gives me 140 degrees. Now check it out. If you look real closely here, you'll see that you have some vertical angles, right? This guy and this guy are vertical. So if this is 40, I know this is 40. And I also know that this guy and this guy are vertical. So if that's 140, this is also 140. So check that out. I found all the angles in the circle. Now, if we're doing this right, this should also add up to 360. So let's just make sure we did this right. 40 plus 40, 40 plus 40 plus 140 plus 140, right? That's all my angles in the circle. 40, 40, 140, 140. That should add up to 360. Let's check. Yeah, it's 360 degrees if you put in the calculator. Awesome. So we're doing something right here. Now let's go back to our problem. We are looking for arc AD, which is right over here. And let's look, our central angle right there is 40, so we know AD is 40 degrees. And then we want to find out what AE is. And so, let me just get rid of this for a second. All these numbers are making me nauseous. I want to find out what AE is. A to E, right? That's this angle right here. AE. And we see that that angle is 140 degrees. Sweet. Sweet. All right, so we did our central angle theorem. Now we're going to do our inscribed angle theorem, okay? And inscribed means when it touches the actual circumference of the circle, okay? So that's what inscribed is. You see how this angle touches the circumference and it doesn't go through the center? It's not a central angle, it's inscribed. This is an inscribed angle because it touches the outside of the circle, all right? So I just want to put a little note here because it's not there. An inscribed angle touches the outside of the circle. That's a bad word. The circumference. Circumference. Okay? So the inscribed angle touches the circumference. So what is the inscribed angle theorem? The inscribed angle theorem states that the measure of an intercepted arc, all right, is double the inscribed angle. All right, so the intercepted arc on the outside is going to be double the inside angle. So, well, let's see. The inscribed angle is 20 degrees. Let me put that in blue. I want to stay consistent here, guys. All right. So my inscribed angle is 20 degrees. The intercepted arc is going to be double. So if the angle touches the circumference, okay, like it does here, it's not in the center, then the intercepted arc is double that. Ooh. So what would I do? What's double of 20? That would be 40 degrees. So my intercepted arc is just, I want to stay consistent here, 40 degrees. It's double it. Now, an easy way to do this is actually use this formula, right? 2 times the inscribed angle, which is on the inside, equals the intercepted arc. Double the inscribed angle equals the intercepted arc. So if I know the inscribed angle is 20, right, and I'm looking for AC, then I know 2 times 20 is 40, and so AC is 40. All right, so you just double it to get the outside. So let's try some practice problems with that. So what is the measure of DG, right? That is my intercepted arc, and I know this is an inscribed angle because it touches the circumference. Touches circumfrizzle, ference. All right, so it's inscribed. So to find DG, arc DG, all I have to do is plug into my formula. So 2 times 50 is going to be equal to, well, I don't know this, so let's put x there, is equal to x. So 2 times 50 is 100, which equals my x. So this outside angle is equal to 100 degrees. This equals 100 degrees, okay? It's just double, the arc is just double the inscribed angle. All right, take a look at this guy. Well, it's a little different, right? This one, I actually know what the arc is. We see that the arc is equal to 120 degrees, and I want to find out what angle B is, right? That's the inscribed angle. So let's put an x there because we don't know what that is. So let's just plug into our formula. So 2 times the inscribed angle, which is x, is equal to the intercepted arc, which is 120. All right, just plug it into my formula. To solve for x, I have to divide both sides by 2, and I just get x is equal to 60 degrees. All right, that is 60 degrees. So B is 60. All right, so for this problem, we're going to try to find the measure of the arc AC. Okay, and what's kind of interesting about this is that AC is not our intercepted arc, right? So that makes it a little harder. What the intercepted arc is CB. Our inscribed angle is 48 degrees, and the intercepted arc is CB. But we're trying to find AC. Well, how can we do that? Well, I know the whole circle is going to be 360 degrees, right? All of this around should be equal to 360. So arc AC plus CB plus AB should be 360. If I could find out what these two arcs are, I could subtract it from 360 and find out what the missing arc is. So let's start off by finding out what CB is, and we'll just use our formula. 2 times the inscribed angle equals the intercepted arc. So our intercepted arc is x, and let's just plug everything in. 2 times 48 is equal to x. We find out when we multiply 2 times 48, it's 96 degrees, so our intercepted arc is equal to 96. All right? Arc CB is 96 degrees. Now to find what AC is, this missing arc over here, all I have to do is do 360 minus 162 minus 96. All right? So I'm subtracting 360, which is the whole thing, minus the 2 arcs I know. And that gives me 102 degrees. And so that tells me what the missing arc is. So AC is 102. Simple as that. All right, for our final question. We know that angle, the measure of angle FGE, is equal to 58 degrees. We want to find the measure of angle D. Now this is weird. We haven't learned a theorem about this, but can we use what we know to solve this? I think so. So we know that our central angle over here, FGA, is 58 degrees. Since we know that the intercepted arc is congruent to the central angle, we know that FE is going to be 58 degrees, right? Now here's what gets a little tricky. What I'm trying to find is angle D, right? And that's the inscribed angle. Well, if you just look over here, we know FE is the intercepted arc of angle D. So we could set up our equation as 2 times the inscribed angle is equal to the intercepted arc. All right? So to solve this, just divide both sides by 2, and we get x is equal to 26 degrees. All right, and that's how that one's done, right? So we just used our central angle to find the arc, and then we took half of this to find the inscribed angle. All right, guys, that's it for this lesson. Nice job.